Today I'm gonna present our paper Detecting Software Security Vulnerabilities While Requirements Dependency Analysis. First of all, let me introduce my co-authors. Farron is an undergraduate student at the University of Cincinnati. Nan is an associate professor from the University of Cincinnati. Glenn is a senior project manager from the University of Cincinnati Library. The last one is me, and I'm currently working with Oracle. Vulnerability detection is a very important problem in software engineering. Missing any vulnerabilities would lead to serious security accident like Facebook data breach. Researchers have proposed many testing approaches to help us detect the vulnerabilities and validate the security requirements. However, most of them focus on individual security requirements, or they validate the security requirements isolatedly. According to Robinson, over 70% of software vulnerabilities are caused by interactions between requirements. Therefore, we think if we have those requirements dependencies, we can easily build the map like this figure, which can help us create test cases to systematically test all the dependency paths, with the hope that it can help us detect more vulnerabilities before we release software projects. However, we all know that modern software may have hundreds or even thousands of requirements. Manually detect those dependencies between them is a time-consuming task. Therefore, we need automation. Currently, the automatic way to detect the dependencies is requirements traceability, or more specifically, vertical requirements traceability. This type of traceability or automation caps the dependence among same type of the software artifacts. In this case, in our cases, low-level security requirements or system-level requirements. However, many research indicates that accuracy of the vertical requirements traceability is very low. The main reason is that those vertical traceability automation is based on TF-IDF. But the low-level security requirements, in many cases, even though they have dependence or depends on each other, they don't share too many terms. And so that's why cause a low accuracy of the automatic requirements tracing. At the same time, we know that according to cybersecurity regulations, all software need to fulfill high-level security requirements defined in those regulations by the low-level software level security requirements. And for this high-level security requirements, as you can see in this figure, if they have the dependency, they may share more terms. Therefore, we can easily detect the dependency between them. And since all the we need to use the low-level security requirement to fulfill those high-level security requirements. Therefore, there's another type of the traceability between high-level security requirements to low-level security requirements. We call it a horizontal traceability. If we can detect those two requirements, two types of the information, then we can easily infer the dependencies between the low-level security requirements. Therefore, we propose this hybrid requirements traceability. The first step of our approach is to manually detect the dependencies between two high-level security requirements. The second step is to automatically trace from the high-level security requirements to low-level security requirements. And the third step, if a low-level security requirement 1 fulfills the high-level security requirement 1, and low-level security requirement 2 fulfills the high-level security requirement 2. If we know there's dependency between the high-level security requirement 1 and 2, then we will say that there's high possibility that low-level security requirement 1 and 2 are dependent on each other. And we want to point out that even though we we manually detect the high-level security requirements dependency, the main reason is that the size of it is relatively small. We can handle it manually, and at the same time, according to our experience, we provide five categories. And we think all high-level security requirements dependencies can be classified into those five categories. And for the second step, we use the fully automatically requirement tracing. There are four variants of this part. The first one is a basic information retrieval method of TF-IDF. And the latest three are extent of it, called relevance feedback, and its three variants. We compare four of them in our experience. We compare our hybrid requirements traceability with the vertical requirements traceability on 5 projects. And the result shows that our hybrid requirements traceability achieve the higher accuracy. Among 4 types of the information retrieval methods, term-based relevance feedback achieve the highest accuracy. With those, like I said, with dependencies, we can easily build the dependency maps, and we can use that map to guide our vulnerability detection. We with the hope that we can find more previous unknown vulnerabilities. Therefore, we take a case study based on the one project Scholar at UC, and we successfully detect the 4 vulnerabilities. We reported 4 of them to original developers. They confirm there are true vulnerabilities, and they start to address them in the GitHub issues. This is our today's presentation. In our research, we first will propose the hybrid requirement traceability approach to help detect the dependencies between the security requirements. And we also provide 5 categories to help practitioners detect the dependencies between high-level security requirements. At the end, we also demonstrate the effectiveness of our approach on vulnerability detection via case study. Thank you. This is today's presentation. I would like to take any question during the online session.
Hello again, everybody. Welcome to this last Q&A for this session about security vulnerabilities issues. I'm here with from University of Cincinnati. It just presented a paper detecting software security vulnerabilities via requirements dependency analysis. So I'm going to ask or if there's any questions for when journal first, the original in TSC.
Thank you, David. Thank you
Vulnerabilities.
for introducing. Yeah, I'm very happy to be here to answer all your questions.
Well, I can start. First, we have maybe a clarification.
Mm-hmm.
So I see that your approach is basically three steps. Uh, and the third step is this in part, right?
Mm-hmm.
I just
Yes.
want to make sure that uh, in this step there's no real it's on completely, there's no real machine learning or applied, or is it?
Okay. So for the third step now, actually, this automatically inferred from the result of but from the previous two steps, right? So I'll give you some example. For example, the high-level security one is implemented by the one low-level security requirement one, right? And high-level security requirement 2 is implemented or fulfilled by the low-level security requirement 2. And if we, in the first step, we found that there's dependency between the high-level security 1 and the high-level security 2, we will think that there's a high that the low-level security requirement 1 and the low-level security requirement 2 are related to each other. So that's why we say if we find this uh, any low-level security requirement 1 in the fulfill the high-level security requirement 1, will have automatically link
Right.
or to the low-level security requirement 1 that fulfills the high-level security 2, right? But yeah, this is maybe involve some false positives in this result,
Mm-hmm.
right? So and well, currently we don't do any machine learning or automatic retracing in this because we want our hypothesis is that security or vulnerability detection, security relationship is very important. We cannot afford to lose anyone, so we want to
Right.
include as much as possible, right? But yes, we I also acknowledge that this, since we will involve so many false positives, right? So it may cause the directly consequences is that the practitioners will have to verify whether this is true when they apply our results, right? But yeah, we think this maybe some other ways, like you mentioned, the machine learning or automatic tracing can help us reduce the false
Right.
positive without, but we want this could be some method that can reduce the false positive, but at the same time without hurting our true positives, right? Without
Mm-hmm.
hurting the recalls, right? And
Right.
that could be our future direction. Actually,
I
that we
see.
mentioned this in our conclusion.
I see. Okay. Thank you very much for that.
Yeah.
And we have an answer from we have a question. Sorry, Fabio Masacci is asking if we have different requirements for a new standard, how complicated would it be to, I guess, it means to adapt.
Okay, yeah. So yeah, this is a good question. Thank you. So now, first of all, the I think complexity comes from two parts, right? One is since in the first step we use manual, now we manually analyze or detect the relationship between high-level security requirements, right? It may cost some time, and in our like in our my presentation, I mean our paper, we think that we all those dependencies between high-level security requirements can be classified in 5 categories. We also provide the how some examples and guidance how we detect the classify each dependency into different classifications. This may with this hope we think they can easily adapt this part into different high-level security requirement sets, right? And for the set part, it's really I think the second part is really hard to for different data set. We may have a different most suitable method, right? So that's why we compare 4 of them, right? For like the basic TF-IDF and 3 feedback, different feedbacks methods, right? So, and with our purpose here is that we want to find a suitable one for security related requirements tracing, right? So if you adapt our approach to it, right? So if you, I think for this part, based on my experience, our results, and I think the term-based relevant feedback is most suitable for the security requirements tracing here in our approach. And this is fully automated. So I believe it's very easy to adapt it to the another data sets, right? But I think but like I mentioned, this is maybe there's some difference between the different data sets. Like since both the TF-IDF and the reference feedback is based on the term. How many terms you share, right? If so, for some special cases, they may have more or less term sharing, right? So I think the term-based feedback is more suitable for the requirements which share less. Original requirements share less than terms, but for the if you have a small set and this set is highly related to each other, they share more terms. So I think it's easy to adapt the TF-IDF. Does that answer your question?
I hope so. But we have also one more question and 75 seconds left. So, interesting work. I wonder how this approach could be used in practice. For example, if a potential requirement is identified, how practitioner could do with it. What should I do?
You mean after they get the results, right? Yeah. So I think that this is if we I think that after you detect the vulnerability, so it's better to so in our case study, we communicate with our developers because they can have to confirm this is a true vulnerability. Actually, this is how we open source vulnerability databases they did, right? So ask experts how to very
10 seconds left.
yeah, and then they have to move quickly to solve it before they publish the vulnerability.